Good morning. This is Sabresh, working as assistant professor in NPR College of Engineering and Technology. Today, we are going to discuss about digital signal processing. Before starting this subject, we will see what is digital signal processing. Okay. So before starting this, we already studied about signals and systems in the third semester, right? So signals and systems, what is signal and what is system? That is the first question. Then only we will go for digital signal processing, right? So before that, what is a signal? A signal is a signal which is having some information. Okay, a signal that has some information. Okay, that signal only we are going to process. In nature, the signals are analog signals. Okay, so we will see the classification of signals. First one is analog signal and second one is digital signal. Okay, in general, the signals are analog signals only. For example, speech signal or audio signal or ECG, EEG, these are the natural signals. All signals are analog signals. Okay, this signal is going to process by means of digital. So the first process in digital signal processing is converting the digital analog signal into digital signal. So we are having two processes. First one is sampling and second one is quantization. By using these two methods, we will convert the analog signal into digital signal. Okay, so in this DSP we are going to discuss about, in the first unit we are going to discuss about DFT, discrete Fourier transform. We will find some Fourier transform and inverse Fourier transform by using of a given signal by using fast Fourier transform also, right? So in the second unit we will design filters. Already we know what is analog filter, like that. In this unit we will design the digital filter. In the second unit we will design IAR, that is infinite impulse response filter. In the third unit we will design FIR, that is finite impulse response filter. Okay. In the fourth unit we will discuss about finite wavelength effect. Finite wavelength effect means a processor which is contain some number of bits only. Okay, here we are going to discuss about digital signal process, how that processor store the information, store the binary digits, like that we will discuss. On that time, what is the error will occur, those errors and noise we will discuss in the fourth unit. In the fifth unit we will discuss about digital signal processor. In this digital signal processor we will discuss TMS 320 C5X and C54X and how to write programs by using TMS processors. Okay, how it differs from microprocessor, those things we will study in DSP processor in fifth unit. Okay, so today we will going to discuss about digital signal processing introduction. Okay, in this PPT we have these are the outlines we are having. Okay, so already we know what is a signal. Signal is a physical phenomenon that carries or convey some information. Okay, some information from source to destination. Okay, this is called as signal. And then we are having two types of signals. First one is analog signal and second one is digital signal. Okay, so what is the difference between analog signal and digital signal? Analog signal is continuous in both time and amplitude, but the digital signal is discrete in time and quantized in amplitude. That is called digital signal. Okay, the analog signal is converted to digital signal by sampling and quantization, right? So next one is signal processing. What is signal processing? Signal processing it is the analysis, interpretation and modulation of like sound, images or some other datas, right? So we are having two types of signal processing. First one is analog signal processing and second one is digital signal processing. Simply signal processing which changes the characteristics of the signal. Okay, so next one is analog signal processing. Analog signal processing, we will use analog signal processor. Okay, that processor, by using that processor only we will do some mathematical operations. But in digital signal processing we are using DSP processors like TMS processor or Motorola processor. By using that processor we will do the processing. Okay, next one, digital signal processing. Already we know what is digital and what is signal and what is processing. Okay, for digital signal processing we need a signal. Okay, first one is signal. That signal is always analog signal only. Okay, but we are using digital signal processor, so the thing is we need a digital signal. So the first process is we should use analog to digital converter. First the analog signal is converted into digital signal, then only that digital signal will be processed by using the digital signal processors. Okay, next one, that digital signal processor gives the digital values. That digital value is converted into analog value, then only we can use in the real time. So on that time we will use digital to analog converter, DAC. We will get the analog signal. Okay, so finally we will use some filters to eliminate the noise that for that. Okay, so the thing is digital signal processing. For digital signal processing we need digital signal process, then before that we need ADC, and after digital signal processor we need DAC. Okay, so next one is need of signal processing. Signal processing, why we are going for signal processing? For a long distance communication, that signal, if we transmit that signal we will get some distortion. Okay, to eliminate that distortion only we are going for signal processing. Okay, next one is principle and operation of DSP. This is the principle and operation which is having anti-aliasing filter, ADC, digital signal processor, and finally DAC, and then reconstruction filter. That reconstruction filter is used in the receiver side, and in the transmitter side we will use anti-aliasing filter. Okay, that anti-aliasing filter is used to convert that analog signal into digital signal, right? So next one is advantages. What are the advantages we are having on DSP? The first thing is accuracy, flexibility, easy operation, and then multiplexing. We can store the digital values very easily. So these are the advantages of DSP. So these are the advantages in having in DSP. Next one is limitations. What are the limitations or limitations of DSP? We will have anti-alias filter in this circuit, and then frequency resolution, and third one is quantization error. These are the limitations of DSP. And finally applications of DSP, we will use in various sectors in image processing, like image processing, consumer applications, cellular mobiles, and then digital TVs, digital radios, in communication, speech and music processing, and then biomedical in radar processing and sonar processing. These are the applications of DSP. So DSP is the main subject in signal processing or in communication. Okay, so today we discussed about what is signal, and then what is signal processing, and then what are the types of signal processing, that is analog signal processing and digital signal processing, and then what is the difference between analog signal processing and digital signal processing, and then we discussed about advantages, disadvantages, and then finally applications. Thank you.